Other than transformer, the following are the other applications of electromagnetic induction. 1. Moving coil microphones. Moving coil microphones are used in public address systems. We have two diagrams here. Diagram A represents the actual microphone with the parts, while B represents the internal functional parts of a moving coil microphone. In this particular microphone, we have a coil wound on a cylindrical former which is connected to the diaphragm and placed between the poles of two magnets. So when sound waves come in from a source, the diaphragm vibrates. The coil then moves to and fro. As a result, the magnetic field is cut by the waves. Since the field is radial, the motion of the coil is therefore perpendicular to the field, and therefore, as a result, we have a maximum flux linkage. As a result, an EMF is induced with varying magnitude, and therefore current is created in the coil. The moving coil microphone is connected to the amplifier, which is used to increase the magnitude by increasing the amplitude of the current. The amplitude of the current needs to be amplified before being fed into the loudspeaker for conversion to sound. The induction coil is another application of electromagnetic induction. Again, here we have two diagrams. Diagram 1 is the actual representation of an induction coil, while diagram 2 represents the functional parts of the induction coil. We have the spark gap, which in the circuit diagram is that. At the same time, we have a few turns of thick insulated wire and a secondary coil of many turns. We have the primary coil and the secondary coil. Both of them are wound on a soft iron core. So we have the soft iron core. The primary coil is connected to a DC current of very low voltage. So when the switch is closed, magnetization of the soft iron occurs, and therefore the soft iron armature is attracted. So we have the soft iron armature here. It is attracted. The moving armature opens the contact and cuts off the primary current, hence reducing the magnetic field to zero. This induces a large EMF in the secondary coil by mutual induction. The springs are there to pull back the armature to reconnect again for current to flow in the primary coil. The process repeats and the induction coil continues to work.